Hi dear students, welcome to the next topic from laws of motions. As I told, this is of course a subtopic and this subtopics needs to be understood before we are jumping to the main topic, which is called banking of road. So today we will see all these topics. So before that, the continuation of the last topic. Last time we have learned about the centripetal force and some other circular motions basic parameters, right? Today we are going to continue that part. So you can write down the heading called centrifugal force. So you can write the heading called centrifugal force. Centrifugal force. What is the difference between centripetal force and centrifugal force? In one shot, formula wise both are same. Formula, there is no difference. Okay, centripetal force is mv square by r or mr omega square. Two formula we have learned, right? It is there in your notebook also. But today in this topic, centrifugal force formula will be the same, but concept is different. Okay, so based upon the question, while you are reading the question for your entrance examinations, you must derive from that whether I need to use centripetal or whether I need to use centripetal force, centripetal or centrifugal force. You must know that knowledge. That's what we are going to derive it here. Okay, so let's see. You have learned about two things in the previous topic, like inertial frame and non-inertial frame. Inertial frame means what? Suppose I am standing here, I am seeing a car is moving in a road. So with respect to me, car is moving, I am at inertia, I am an observer. So as an observer, I am standing and the frame of reference is the ground. Ground is not moving, but at the same time, what is actually moving? The car is moving. This is called inertial frame because the frame of reference, with respect to me, I am a frame of reference. So with respect to me, car is moving, I am at inertia, at rest. So I am not moving. That is called inertial frame. We learned about a non-inertial frame. What is an example of a non-inertial frame? Suppose I am inside the car and the car is moving. So with respect to the car, I am also moving. So if I am looking, car is moving, I am also moving. So me is called an non-inertial frame. So for a non-inertial frame, we have learned a special term is called pseudo force. Hope you remember that term is called pseudo force. Pseudo force will act opposite to the direction of the original force. Okay, so let's take an example. Of course, this example I have already mentioned to you. Suppose we have a cart. Cart means just a vehicle, and a mass is attached to this one, small letter m. Okay, let me make it bigger. A small letter m is attached. If the vehicle is moving very fast, so you can see the vehicle, on this vehicle, the body m is attached. Okay, so our attention is on the body m. Okay, this is our attention point. This is what is important to us. So with respect to this one, this is attached in a vehicle. It is connected with a vehicle and the vehicle. If the vehicle is not moving, there are two situations there. If the vehicle can move or vehicle is not moving. So I will take a two situation. Vehicle is not moving. Not moving. Second example, vehicle is moving. If vehicle is moving, then we have something called pseudo force will be here. Pseudo force, if pseudo force is available only, I can use Newton's laws of motion. I already mentioned to you this. So if this is moving with an acceleration called a, then I know F is equal to ma force will be there in the forward direction. So this m will have a pseudo force. Actual force I know F is equal to ma in the direction, because the frame of reference means on the frame where the m is attached. M is attached with this frame, and this is a car or this is a vehicle, and this vehicle is moving. Then what is exist? Pseudo force is exist. Pseudo force is acting against the direction of the original force. So this is the original force. Original force is ma in this direction. So while we are drawing the free body diagram of this one, we will say ma is applying opposite to the direction. This is a non-inertial frame. This is a non-inertial. Inertia means rest. Non-inertia means not moving. This is an inertial frame. If it is not moving means inertial frame. If it is moving means it is called non-inertial frame. Next, suppose if I am assuming there is a frictional force will be here, there is a frictional coefficients will be here mu. So if I draw the free body diagram of this block M, then I can say mg is acting downward. There is a chance these blocks to move downward, but there is a frictional force F. Frictional force equal to what? Mu into N. Normal reaction is always towards the body. It is like a contact force. So there is a normal reactions like this, and there is a pseudo force like this. So what is the condition that this block will not fall down? I can say frictional force must be equal to mg. In that case, the blocks will not fall down. So this is an example of a moving frame. Okay, so this case can apply when it is moving frame. If it is not moving, we can apply the other condition because MA is in the forward directions. If the cart is not moving, here whatever I am going to explain to you is about the concept of non-inertial frame. Non-inertial frame, which means the cart is moving, vehicle is moving, and M is attached to the vehicle. Then a pseudo force. Where is the original force? I am moving forward. So pseudo force is opposite direction. That's what MA is acting. So mu into N is equal to mg in this case. What is called N? N is equal to MA. Okay. Two opposite forces. There are no other forces. So opposite forces are equal. So N is equal to MA means mu into MA is equal to mg. M get cancelled. So the coefficient of friction is equal to G by A. Okay. So in short, I can say if mu is greater than or equal to, if mu is greater than or equal to G by A, in that condition, I started the condition F is equal to mg, which means upward force and downward forces are equal. If that is exist, the block will move upward or the block will move downward. Block will never move, right? Because both forces are equal forces. So with that assumption I started. So if the coefficient of friction, which means the roughness of the surface between the vehicle and the mass M, must be greater than roughness, that is the coefficient of friction. If mu is greater than or equal to G by A, if this condition exists, the block M will not fall down, the block M will not fall down. If mu is greater than or equal to, so this is a minimum value of mu. This is a minimum. Equal to means minimum. So mu can be any value greater than this. So this is the minimum value, and maximum value means greater value. So the minimum condition is either it should be equal or it is greater than G by A. If that condition is met, the block will not get moved. This is the best example of a pseudo force, or that is the best example of a non-inertial frame, because the frame means where I am looking to the mass M, and the mass is attached where? Mass is attached with a moving block. Then it is called non-inertial frame. If non-inertial frame will be there, what will happen? Something called pseudo force will available. Pseudo force must available. If pseudo force must available only, you can draw the free body diagram and you can write the equations. So you can't write any equations without the pseudo force for a non-inertial frame. And this chapter, the core chapter is Newton first law, second law and third law. So all the Newton laws means F is equal to ma. So you can apply Newton laws for an inertial frame, for a non-inertial frame. If you want to apply for a non-inertial frame, the mandatory condition is that you have to consider what is called pseudo force for a non-inertial frame. This is all the concept. Now I am not talking anything about the centrifugal force, right? So far I am speaking about centrifugal force. So I am not talking anything about this term is a single term, not a double term, right? Centrifugal force, like this, single term, centrifugal force. So I am not talking about centrifugal force. So far I am only speaking with you what is called inertial frame, non-inertial frame. You will think about He is speaking about a inertial frame, non-inertial frame, but his heading is centrifugal force. Correct. I have yet to come to centrifugal force. In order to understand about the centrifugal force, you must know what is the difference between inertial frame and non-inertial frame. Even though I have taken in the previous topic also, I just want to revise it for you again. I know it's a wastage of time, at least now. Okay, but those who have remember what I have talked in the previous classes, definitely they will remember all this stuff. This is I just taken as an example to revise the topic. So hope you understood what is the difference between inertial frame and non-inertial frame. Next, come to a topic, centrifugal force. I told, while I am starting this topic, I told the centripetal force and centrifugal forces both are same. There is no differences, but difference in the sense formula wise it is same, but concept wise it is different. Remember one thing, centripetal force can apply when the object is, question is simple, when the object with respect to the frame of reference. So we look into the object and we look into the frame of reference. In short, I can say centripetal forces can be used for a inertial frame. This is important. This point you have to note down on your notebook. Centripetal forces can be used for a inertial frame. Centrifugal forces can be used in a non-inertial frame. Okay, F is equal to ma, Newton's second law. What is the equation of a pseudo force? F is equal to ma. What's the difference between these two? Directions are opposite. Why directions are going opposite? Because one is inertial frame, one is non-inertial frame. So in a non-inertial frame, direction is opposite to the inertial frame condition. Same stuff will be here. Centripetal force and centrifugal forces are opposite direction. Okay, so 3 points I told to you. All the 3 points should be there on your notebook. Okay, point number 1. Centripetal force and centripetal force can be, if you have not written the notebook, you can write down. Centripetal force can be used in a inertial frame. Second point, centrifugal force can be used in a non-inertial frame. Third point, centripetal force and centrifugal force are in opposite direction. That's all. So story is over. So centripetal force, I know within a circle centripetal force is always acting towards the central. So the centrifugal force, where it will act? It will act always towards outside. Okay, centripetal force will act towards the center and centrifugal force will act towards opposite. So in short, have a 3 points to you. The number 1 point, centripetal force in which frame? Inertial frame. In an inertial frame. Centripetal force in an inertial frame. Second one, centrifugal force. Centrifugal force in which plane? Centrifugal force in non-inertial frame. Non-inertial frame. This is my second points to you, right? Third point, centripetal and centrifugal force. I am representing FC. FC is equal to centrifugal. I am just representing FG. This is my notation only. Is equal to mv square by r magnitude wise, or it is also called mr omega square. So you can write this as additional point. Magnitude is same, but in opposite direction. But in opposite direction. Now we are going to see more about centrifugal force. Okay, so we are going to see more about the centrifugal force. This is of course your centrifugal force heading. Centrifugal force. So all these 3 points you have to remember. Now let me take an example and I will show to you how we can apply these concepts. Okay. So the frame of reference where the object is placed, that frame is moving. Then we have to apply centrifugal force. I'll take an example. Suppose you assume you have a desk like this one. You have a desk like this. You have a desk. Okay. So the disk is rotating. And suppose you have placed a coin will be here. Okay, so two things, this is a disc, this is a coin. Okay, so a disc and coin will be here. Okay, at what angular velocity, question is like this one, at what angular velocity the disc, we can take this as an example number 1, our first example, our first question, to understand the concept. At what angular velocity the disc has to move so that, at what maximum angular velocity the disc can move, so that the coin will not throw away. So if you see something like a question will be like this one, you don't know, because if you read the question, at what angular velocity the disc can move so that the coins will not throw away, because the question is asking what maximum angular speed at which the disc can rotate so that the coin will not fall down, right? Suppose if you have taken a normal disc and if you placed a coin and if you rotated the disc, if it is very fast, what will happen? The coin will just go away, fall down. So here the question is, at what maximum angular speed you can rotate so that the coin will not fall down? Well, you see this question, disc, there are chances will be there while you are seeing the question in disc. Disc we are very commonly using in rotational dynamics chapter. But if you see the question, two hint will be there for you. One is the disc is rotating in a circular fashion. So you know that is a circular motion example. That is very clear. Second point, here coin will be there and coin is resting on a frame. What is that frame will be here? Disc. And that frame is rotating, which means frame of reference. Frame of reference is rotating means what is we have will be here. We have a centripetal force towards the center or centrifugal force away from the center. We have no centripetal force, instead we have centrifugal force. Okay, here disc rotating, this is example. Then what is exist will be here? Centrifugal force is exist. Suppose you take another example. You have a disc like this. Okay, disc not rotating, but you have a coin will be there. Coin moving. Here coin is moving. Yes, coin is also moving, right? Coin is also moving. Moving means it is not in the same positions. Coin will be there, or you can consider just coin is moving in the sense, do not confuse these differences. Okay, why I'm saying disc is rotating and coin is on the disc. So if disc is moving like this one means I can say coin is also moving like this one. The all together, it's a system is moving. So coin moves, I can say, along with the disc. This is one example I'm saying. So you don't want to get confused. Along with the disc and coin is moving. Okay. In this case, disc is not moving, disc is rest, but the coin is rotating. Then what will happen? The frame of reference where the coin is placed on the disc and the disc is rotating, in this case not rotating. So what will act towards the center? We call it as centripetal force. But here disc is rotating, so no centripetal force will be here. Here we have something called a pseudo force. What is that pseudo force? Is called centrifugal force. Centrifugal force is acting will be here. Centripetal force is acting will be here. Because the frame of reference here it is called disc. Disc is not rotating, so centripetal force, because the coin alone it is moving over the disc. But here disc is moving, coin is attached to the disc and both are moving like this one. So the reference, the frame of reference, frame where you are standing, this is your reference point, disc, and the disc is moving. So you don't have any centripetal force towards the center. Instead you have something called centrifugal force, just opposite to that. Okay, so for example, if you circle like this one, if your centripetal force is like this, I can say centrifugal forces are like this. So two options will be there. You can decide whether you are going to take FC or you are going to take FG. That is up to you. Up to you, in the sense up to the question. You have to read the question, which are for JEE or Neet, whatever it is coming for the entrance examination, whatever it is coming. Analyze the question, use your brain. Then decide, okay, centripetal force. No, so not centripetal force, centrifugal force. Decide it and then apply, because formula is same but concept is different. That's what I say. Physical concept is different. Here disk is not rotating. Disk is stationary, so centripetal. Disk is moving, so that is called centrifugal, no centripetal. Any one will exist. Depends upon the frame of reference. If it is non-inertial frame, non-inertial frame means non-rest, means which is moving. Hope you understood the point. Okay, now this is I just explained to you to get the concepts very clearly. Next, I'll come to, you can note on all the steps, of course. Now we'll come to the question, at what angular velocity disk can move so that the coins will not rotate. Now I'm taking only this coins part will be here. Just the coin parts will be here, and this will have a centrifugal force left side, and if the disk is rotating, coin will be there. If the disk speed is keep on increases, we need to find out what is the maximum angular velocity. So at certain point the disk will go off. So somebody has to pull its center. Who is pulling towards the center? That is called frictional force. And we have two things will be here. Its weight always downward mg, and the surface will be giving a normal reactions which is upward. We have to equate all these equations. Opposite forces are equal, so frictional force F will be equal to centripetal force. F frictional force equal to mu n, which is equal to mr omega square, because they are asking angular velocity. That's what I am using, mr omega square. We have two formula, right? mv square by r or mr's omega square, both are same, but here angular velocity is asking, so I put the equation in terms of angular velocity. Mu into what is n? N and mg are equal. Mg is equal to mr omega square. M and m will get cancelled. So balance I'm writing to here. So I can say omega square will be equal to mu g will be here. So it is mu g divided by r. So omega, what maximum angular? A maximum means this is a maximum value, is equal to root of mu g by r. This is a maximum angular velocity. I can rotate the disk so that the coin which are placed on the disk will not get fall down. If you are increases the speed of the disk beyond this limit, mu, you can play the value of mu, right? Because of mu will be depends upon the roughness of the surface, but g is given by the God, you cannot do anything will be here, and r is the radius. So our radius should be smaller, so you can increase more omega. Frictions will be higher. More friction means more grip will be there, so you can further increase omega. That is a criteria. So this is a maximum value of omega you have to give so that the coin will not get fall down. Okay, hope the question or the stuff which is very clear to you. Okay, so centrifugal force, centripetal force, equation wise mv square by r or mr omega square. The point is like, if somebody will come and ask where you will use centripetal force, where you will use centrifugal force, you have to say, hey, if you are using non-inertial frame, you are using centrifugal force. Hey, if you are using inertial frame, then you are using centripetal force. This is a whole about the concept. So we are moving to the next major topic. This is actually, so far we have learned is the supporting information. Last 2 to 3 sessions we have learned about the supporting informations, which we are going to take it forward into the topic in which we are going to discuss it now. This is a major area. Okay, so turning of a car, write down, important, turning of a car on a level road, okay. So different factors will be here. Okay, turning of a car on a level road. Okay, so let's consider. So we have scenes like a curved road like this one, right? So normally car will be there on a straight road, or instead of this one I can put it like this. Car will be there on a straight road. Okay, so this is a car, this is like our car, and the passengers are inside the car and the car is moving. Okay, so car is moving, so I am a passenger. Okay, so the point is like, question is like, at what maximum speed can go without skidding? Without skidding, we are not supposed to skid without skidding. Skidding means you know, right? Either we will go out or go into the track. We should be in the proper road. So if it is going like this one, then road will be there, but I am a passenger. I am looking, I am inside where? Car. I am inside where? Car. Car means I am in a non-inertial frame. Okay, so instead of taking the diagram will be like this one, this is what I need to do. It's a plain road, suppose it's going like this. So this is a car going, so opposite, and this is if you're considering this is like a big circle will be there. If the road is going like this one, for example, going like, then there is a center area will be there. Center, what force will act? Centripetal force. If you say, I'll say you are wrong, because I am a passenger inside sitting the car. I am an observer. I am in a non-inertial frame. So opposite to centripetal force, what will act? Centrifugal force will act. And here what is there? Normal. Here what will be the centrifugal force will be here, means because of the centrifugal force the car can skid and go out. This is out of the road, so somebody has to pull it inward. Who is pulling will be there? Frictional force is pulling inward. Frictional force exists between the road and the tire. Then there are two forces will be here. What are the forces will be here? Normal reactions will be here and weight will be here, mg. So I can say this is an example when frictional force must be greater than or equal to Fg, centrifugal force. Centrifugal force, gravitational force is coming to my mind. Okay, yeah, that is a chapter we yet to learn. That is almost at the end of your physics climax videos. Okay, so F is greater than Fg. If the frictional force is sufficient, the car will not skid and go outside. What is F value? Mu into N should be greater than or equal to mv square by r. Question is asking maximum speed v, not maximum angular velocity. So that I used this equations. What is N? N and mg will be same. So mu into mg must be greater than or equal to mv square by r. mv square by r. So m will get cancels. So v is less than or equal to root of mu rg. So what is the maximum? The value of v should be less than this. Then we are in a safe speed, no problem. But what is the maximum speed I can go? Max means is equal to root of mu rg. This is called the max. V max equal to root of mu rg. Okay, what is this actually indicated to us? Suppose you are assuming you are driving a car in a rainy season. Rainy season means suppose you are driving in a car and your father is sitting on the left, on the co-driver seats. So of course if you put an accelerator, definitely he will say, no, go slow. He will definitely say go slow. Why we are saying? Because if it is in a rainy season, the road is also filled with water, so there is a high chance that you may skid it down. If road is filled with water means the coefficient of friction mu is lesser. If the value of coefficient of frictions mu is lesser means there is a high chance to skid it down. For that you have to reduce the speed because v is directly proportional to mu. If you have enough friction will be here. If you have enough frictions will be there, you can increase the speed because in a normal sunny day you can increase the speed. And if it is a rainy day, you cannot increase the speed. So this is a maximum velocity in which you can go in a turning off on a level road. Here we have considered about friction. Yes, we have considered about friction. So you can say with friction. Okay, so we have learned about with the friction. There is a maximum velocity in which you can move forward so that the vehicle will not skip. So we have learned about the plain roads, what is the maximum speed at which I can go without skidding. Now we will learn about the turning of a road on a curved road. Curved road, or this is also called banking of road. This is actually the real topics in laws of motions. To understand, to come to this topic, that's what we have seen all the previous circular motion topic, because if you understand that only, this will be easily will be getting understood, else this is like a mug up study. So I don't want to do like that. That's what I have taken the previous topic. So turning of a car on a curved road, this is also called a banking of road. Normally in your practical life, in the real life, we have seen like if you have a very sharp bend will be there in a road, a curved road will be like this one, then most of the time you have observed like the one side of the road is higher than the other side, or I can say the thickness of the tar in one side is higher, other side will be lower. So this is a kind of a slope will be like this. So vehicle will go like this one, and we have a slope. So we'll be actually in a turning situations. We can see very visibly, we can see while we are traveling over a two-wheeler, right? If it is a very bending turn, then all the two-wheelers will be like this position instead of they are standing like this. So this is a turning effect, okay, on a curved road. So the road will also have a slope like this one. So to adjust to that stops, we are maintaining certain speed. So there are two things will be there. There is a maximum speed, okay, I can travel in that road in a safe way. Suppose if it's a covered road, suppose I'm assuming 50 km per hour is my maximum speed. So beyond that, if I'm further increase that speed, what will happen? I'll go out of the road. I will go out of the road. But if I'm decreases the speed very much, what will happen? If I am traveling in a road like this one, and if I'm decreases my speed, means I will fall down towards the center. So there is a chance of skidding will be there. If I'm increase a very high speed, then I will go out. Skidding chance will be there. I can go with a maximum speed. There is a certain limit. Beyond that limit, if you go, you will throw out of the road. There is a minimum speed also. You are not supposed to skid inside. You are not supposed to skid outside. So in order to prevent outside means you are traveling with a high speed. If you are increases the speed beyond certain limit, you will throw it away. So that is a maximum limit. But if it's a minimum limit, means you have to still maintaining a certain average velocity so that you can smoothly turn the road. But if you increase the speed very much means you have a chance to skid inward. So there are two situations. Either you will skid inward or you will skid outward. Okay, so two situations we will see. So we will see skidding towards inward of a road. Okay, skidding towards inward. We are skidding towards inward. So as I told before, we have a sharp bend will be like this one. So the road will have some lines will be placed in the road like this. This is a road lines. We have placed the lines will be like this one. Now we are assuming VR will be here, our vehicle will be here. So this is at certain angle, right? With horizontal, this is making some angle called theta. So this is actually our car is located. Now if I zoom this area and if I draw it like this one, then this is the scenario. Car will be here. It is little bit tilted because here tar thickness will be higher, here it is less. So it's a slope towards the center. Okay, I am a passenger. I am sitting inside the car. Car is also moving. So with respect to me, if I am looking to this system, centripetal force will be here or centrifugal force will be here. Centrifugal force, because I am an observer, I am also moving my frame of reference. Frame of reference means where I am sitting. I am sitting on the car or in the car. If I am sitting in the car means car is also moving. So I am in centrifugal force situations. So now we are going to draw the free body diagram for this one. So we are marking all the forces. Here we have something called a centrifugal force. Okay, here we have something called our weight mg. I'm assuming the car with the passenger weight mg, and we have something called normal reactions towards the centers like this. Okay, and minimum speed means there is a chance to skid inward. Okay, so to find, so minimum speed means if I am going with a normal speed like this, suddenly all of a sudden if I decrease the speed means I will skid inward. I will skid inward if I decreases the speed. If I increases the speed means I will go out. So here I am going to find out skidding inward. To skid inward, I have to, I am all of a sudden decrease the speed means I will come inside. For that, the frictional force should act outward, F. Frictional force should act outward. Next, I'll assume a normal line like this one. Suppose if this angle is theta, this is how much? 90. If this 90, this is how much? 90 minus theta, right? This is 90 minus theta. The total is 90. Total here to here it is 90. So if this is 90 minus theta, then what is the small balance angle will come? Theta will come. If this will theta will come means, see opposite, see this is 90 minus theta and this angle is theta. So I am removing this line. Okay. So normal, the normal with, let me make it little more clear to you, the diagrams. Okay, so this is a line. Let me, this angle, the slopes will be equal to theta. Let me see, I want to find out this angle. This is what is my aim. How I can do this one? See, it's quite simple. This angle is theta with horizontal. So this line with horizontal. So which means what is this angle? This is also theta, right? This angle is theta. So this means a horizontal line and an inclined line. Here also horizontal line and an inclined line. Angle is what? Theta. Angle is called what? Theta. So what is this angle will come? This angle is 90 minus theta because total is 90. So here theta will go means this is 90 minus theta. F with the n both are perpendicular 90 degree. If this is 90 minus theta, then what this will come? Theta. So that is quite simple. Theta here, 90 minus theta and theta here. Okay. Now we are redrawing the circuits again. Now once we get n, the side nearer to theta is called n cos theta and the other one horizontal is called n sin theta. This is one case. So n is splitted into two components. Similarly, I am going to split f also will be here. F will be taken to here. F into cos of, okay, adjacent side, cos of, what is this angle? 90 minus theta. Then one line will be coming, will be here. F into, what will come? Sine of that angle, sine of this angle, sine of 90 minus theta. Theta ke pakkathil irukana angle. The angle nearer to theta. Okay, it's called cos theta. See here theta. So n cos theta. Here it is 90 minus theta. So F into cos 90 minus theta. Okay. So now what all the terms will be coming? So here diagram is followed. We have f cos 90 minus theta is f sin theta. Here f sine of 90 minus theta is equal to f cos theta. Now we have all the equations. Now if the vehicle has to go in a stable position, all the forces acting on every side should be equal. Then only the vehicle will be go in a standalone position. So upward force equal to downward force, or you can apply the sign convention, n cos theta plus f sin theta minus mg is equal to 0. So first equations we are writing n cos theta plus f sin theta is equal to mg. This is our first equations. We'll move to the second equations. Second equation what? N sin theta left side. Fg will be equal to on the right side. So I can write as n sin theta, left side and right sides are equal, right? So if you are applying sign convention also, right minus left is equal to 0. Top minus bottom is equal to 0. Top minus bottom is equal to 0 means top is equal to bottom. Right minus left is equal to 0 means right is equal to left. So n sin theta is equal to what are the right side? Fg. Fg means what? Speed we are finding. So mv square by r, not angular speed. V minimum we are going to find out. mv square by r plus f of cos theta, equation number 2. Hope this is you understood. Now I need some more spaces, so we are skidding inward. Okay, so frictional forces are in opposite direction. So I am clearing this area. I need some more space to get a better equation for this. Okay, so okay, now what I am taking means all the terms I will take into left hand side. The first equations I am rewriting again. N cos theta plus, instead of f means what? Frictional force, mu n sin theta is equal to mg. Second equations, n sin theta. So n sin theta, f cos theta. So n sin theta written here. F cos theta taken to left hand side. So it become minus mu n cos theta plus is equal to n sin theta is equal to right hand side, what is mv square by r. If you divide these equations with these equations, what you will get? Equations, again this is equation 1 only, this is equations 2 only. I substituted for f, and f cos theta taken to left hand side, so it become minus mu n cos theta. All n will get cancelled, so what you will get? Cos theta plus mu sin theta whole divided by sin theta minus mu cos theta is equal to what will come? G by, so I can say gr by v square. Both numerator, I am assuming numerator and denominator is dividing here. Both numerator and denominator is dividing with cos theta. So what shall I? Cos theta by cos theta 1. Sin theta by cos theta is called tan theta divided by sin theta by cos theta is called tan theta. Cos theta by cos theta is called 1. So minus mu is equal to g by v square. Gr by v square. We need to find out the minimum speed. So v, this is actually our v minimum. We are skidding inward, and v square equal to what will come? Rg into root of tan theta minus mu whole divided by, okay, let me make one more step so that it will be clear. V square is multiplying, we are cross multiplying. So v square into 1 plus mu tan theta is equal to gr into tan theta minus mu. So v is equal to root of rg into tan theta minus mu whole divided by 1 plus mu tan theta. Rg into tan theta minus mu. Is divided by 1 plus mu tan theta. This is the expressions to find out what is called a minimum speed. This is the equations, and here v is equal to v minimum. This is the minimum speed I can travel so that I will not skid inward. So this is important. Okay, so skidding inward we have seen. So what will be the chances? Will be the skidding outward. Okay, so first topic is over. Equations note down. Okay, you don't want to by heart, but you must know skidding inward means, if I am skidding inward means my frictional force should be outward. So this is clear. Fine, perfect. Next one is called what? Skidding outward. Next one, skidding outward. So we are going with the maximum speed. Beyond that speed we will skid outward. So the frictional force towards the center F, normal reaction here N. As I told before, this is mg line, and there are two things will be here. This angle is also called theta, so it become n cos theta, and this become n sine theta, maximum speed. So centrifugal force outward Fg. Now we will write the couple of equations for this one. What are the equations we can write? Fg. Fg is equal to, or left hand side first n terms will take. So n sine theta plus, this is, if this angle is theta, what is this angle? This angle is also theta. Opposite angles are equal. So we have two components will be here. One is called f sine theta and this one is called f cos theta. So n sine theta plus f cos theta, left hand, two left hand forces will be here. These two left hand forces and this right side. So n sine theta plus f cos theta will be equal to Fg. Equation number 1. Second equations, upward forces n cos theta is equal to f sine theta plus mg. Second equation, equation number 2. We are taking all the n terms, all the f terms towards left side, then we'll solve. So n sine theta plus f mu n cos theta is equal to mv square by r. Then second equations, n cos theta, f sine theta taken to left side, so it become mu n sine theta is equal to mg. This is again equation number 1, equation number 2, just altered. I am dividing LHS and RHS of these equations are dividing. So what will get? N will get cancel it outside. So first next steps will be equal to sine theta plus mu cos theta whole divided by, what is coming? Cos theta minus mu. So cos theta minus mu sine theta is equal to v square by rg. Okay, v square by rg. Both numerator and denominators I am dividing with cos theta to get tan theta, that's all. So sin theta by cos theta, tan theta plus mu whole divided by 1 minus mu tan theta is equal to v square by rg. So v is equal to, how we can write? V is equal to root of rg into mu plus tan theta whole divided by 1 minus mu tan theta. 1 minus mu tan theta. This is the expression for what? Here v is equal to v max. So this is a maximum speed at which I can go, so that I will not, if I am going with maybe some 100 km per hour, then I am going towards the border of the road. If I am increases from 100 to 110, then I will go out of the road. So I have a chance to skid out. This is inward. This is outward, so I have a chance to skid outward. So friction should be inward. If you are skidding, outward means friction should inward. So friction will be here. So this is a maximum speed at which you can travel in a safe side, so that you will not skid outside. Okay. So this is a maximum speed and this is a minimum speed. So based upon the question, you have to answer it correctly. Okay. Next step, I have to give you some few hint or few points from this one. Okay, fine. Okay, so in the last sessions, just before the sessions, we have learned about level road. Okay, I told the just before heading called level road. In level road, what is the value of theta? Theta equal to 0 degree. So tan 0 equal to 0 degree. In that cases, what is the speed? What is the speed I can travel with this one? V is equal to Rg into mu plus tan 0 whole divided by 1 minus, root is completely 1 minus mu into tan 0. Tan 0 is 0. So what you will get? V is equal to root of mu Rg. This is what is expressions we have seen before for a level road. So level road, you can find out what is the maximum speed I can go. Maximum speed means I can go with a safest speed. I can say maximum speed means safest speed, because I am not skidding outside, right? So beyond this limit, I will skid outside. So this is a safe speed I can go. So beyond that, if you are, this is a minimum like speed. This is equal to this, which means maximum speed I can go. If I am increasing beyond this limit, what will happen? I will skid downward. This is one case. For example, let me consider in an inclined road. Okay, inclined road but it is smooth, inclined road but it is smooth. This is another condition. This is level road, one condition, level road. This is second condition, inclined road but it is smooth. Smooth is equal to, what is the meaning of this one? No friction, but it's an inclined road, so theta will be there. So V is equal to, if mu is equal to mu 0, you are substitute, what you will get? Rg tan theta will come. V is equal to Rg tan theta. Sometimes you can simplify this, or you can write tan theta is equal to V square by Rg. Always remember, this is for an inclined road, tilted road, but it is smooth. It is a smooth road. It is a smooth road means what? It has no friction. If it has no friction means tan theta equal to V square by Rg, and this is a level road with friction. Level load with frictions. If it's a level road without friction, nothing will be there, then we cannot drive, right? Level road without friction means mu is equal to 0. Level road smooth, mu is equal to 0. You cannot drive without friction. You must have friction. So here if you have a friction, if the question is specified, it's an inclined road with friction. Remember the point. In an inclined road with friction, incline means theta will be there, that is the meaning of this one, and with the friction you can drive with the safe speed like this without skidding outward. You will be in a safe speed, maximum speed you can travel like this one. Even if in a level road, then this is the equation for a level road. This what we have seen before also, but from this equation also we can go like this. And the another point is like, if it is an inclined road but at the same time it is smooth, the question is specifying it is smooth. Wherever if you see it is smooth means you can take mu is equal to 0, which means the coefficient of friction is equal to 0. Hope you understood banking of road, level road, inclined road, and inclined road without frictions. Okay, so see whether it is smooth or not smooth depends upon, you can apply the coefficient of friction. Hope you understood that. So to have the centrifugal force and how the things are working, I have went through the circular motions topic. So hope you understood the banking of curve, and we have few more. We almost completed I can say 85% of the chapter. 15% small things will be remains there, but it is quite easy to understand. Okay, and we will see with the next topic on the next session. So all the very best and enjoy the study with physics. Thanks.